Okay, good afternoon. Can you see my screen? I'm sharing my screen now.
Nampak benda.
Okay. So just want to brief a bit lah about the course informations. For this is lab 1 degree subject. The code is KCS 2101. So basically there are two parts of lab. First one is what? Fluid mechanics. And second one is strength of materials. Okay. So there's no final exam for the subject. So basically you will be working with the report and some lab sheets that you need to fill up, and also observations lah. Okay. Okay. Have you checked the e-learning? I have uploaded all the materials. This one. So the first part here, first week, all the one that related to fluid mechanics, and then the second week include the some strength of materials lah. Okay. Okay, before we proceed, please mark your attendance for today. Just let me know once you're done.
Saya punya e-learning tak ada lagi.
Kenapa? Kenapa tak ada lagi? You tak tagging
Belum je sebab saya baru nak daftar.
Oh, you baru nak daftar.
Ah,
Apalah. How about Rushwini?
Dah madam.
Okay, then. Apa nanti next class you just remind madam balik lah. Okay. Okay, so since there's no final exam, so you'll be working with report and some observations. So these are some of the assessments, but basically you will be working with 10 experiments. Okay, 5 experiment for fluid mechanics, another 5 is for strength of materials. Okay, so basically here you see there is a close-ended including your report and also observations. Okay, so the open-ended and observation is apart from these 10 experiments. So it's not additional, or it's not separated. It's a part of your 10 experiments. Okay, so since the subject has prerequisites and fluid mechanics and strength of materials. Okay, so means that you have taken the two subjects. Either if it's not pass, but still you have experience take the subjects, and this is okay. Okay. I already informed that my last day will be around 15th of May. So I will double the classes based on the week. So if you check in the e-timetable, basically you will meet only once in a week, right? Okay. Um, and it is supposedly we have one briefing, one lecture, and also one hour for the demonstrations. Okay, but since for the starting semester we have to uh, start the class online. Okay, so basically I will work those 2 hours for briefing, that means for the lecture. So I just want to ask if you able to come to Unicel after Raya able to or not, because you need to complete the lab sheet with the technicians, with Mr. Mozani, Mr. Mok. So this is the lab, so the group work is conducted. So there is no individual task. So Hakim and Rushwini lah, you have to discuss among yourself and let me know.
Okay, madam.
Okay. Mr. Mozani are available lah after Raya. Okay, so that means we are having for this week, for these 2 weeks for the lecture we double schedule lah. And then for after Raya you have to deal with technician for demonstration lah. So Mr. Mozani will conduct the demonstration. You need to contact him and discuss about the time that you need to enter the lab. And then, okay. Here. See, it's already separated and sort properly all the materials regarding the experiments. Okay. So here, for each laboratory for fluid mechanics and also strength of materials, you have laboratory sheets that you need to fill up. Okay. Laboratory sheets. Yeah. And then so the technician will conduct 1 or 2 experiments. So this is the things that should be conducted lah after Raya. Okay. So there are some rubric for the lab report and also observation that you need to download and have a copy for this one lah. Okay. So later on I will create a submission for each lab in the e-learning so that you can upload. Okay, so everything that you have here in this week 1 and week 2 should be downloaded and edit according to your details. Okay, for Hakim and Rushwini, fill up. For any signation, just have it as just put your digital signature lah. Okay. So for each lab report, there is a front page. Okay, so see here, front page lab 1. I only upload 1 sample so that you can edit for other labs. Okay, this front page for lab 1 is an example for experiment 1. But this front page you can edit. For example, the name for the experiment 1. So if you want to submit for experiment 2, so please edit and change to experiment 2. Okay, put the name of the experiment and so on lah. This is front page. Okay, so this front page is the cover page for your lab reports. So you need to make sure all details are complete and put down your digital signature. Okay, so same thing for another lab, which is for the strength of materials. Okay, so it use your this front page, and then the next page will be include your table of content and your reports. Okay. Okay, you have any questions?
Tak ada, madam.
Okay, so this is the things that you need to make sure for each labs. Okay, this one I just put reminder, but this one I didn't put for week 1 lah because this is the same thing. Sorry, I put sorry. So you have front page. Okay, so this is the according to the format lah, ISO format, and then you have rubric. Okay, rubric that you have to put here lah. the lab report and the observation combined. And then you have table of content. So these are the item that you should include in your reports. Okay. First one, table of content. So the table of content will list your content and the page number and so on lah. And then it should be followed by introduction, objective, theory, apparatus, procedure, result, analysis and discussions, conclusion, recommendation and references. Okay. So there will be similar things lah for your SOM reports. Okay, strength of materials report. Okay, any questions before I proceed for the experiment 1?
Madam, kita nak kena hantar ni dalam
You see here, I already put the reminder here. Submit experiments 1 until 5 before 3 May.
tak like handout tu nak kena submit dekat madam ke ataupun dalam e-learning cukup?
E-learning. Nanti saya create assignment for you to submit.
Alright, so tak payah print lah.
Tak payah print.
Okay.
Okay. But you need to combine lah everything that you need to combine. Later on, you just submit one PDF file for each experiment. Experiment 1, one PDF file. Experiment 2, one PDF file and so on. Okay, I will show you the example for this sample of report. I am strict with the plagiarism, so make sure you don't have similar copy with other students. So this is the second page after your front page of your lab reports. So this is one, but this is not the best lah. Okay, so I would suggest you to include the page number lah sini. Okay, so what is the content inside? You can refer to the some of the lab sheet that I will give it to you. I will explain after this. So this is the purpose or aim, objective. Like this one, no need to have. You see here, this is what. Let's say I'll show you for experiment 1 lah. See. Experiment 1 is about hydrostatic force and center of pressure. Okay, so everything here is in the report that you want to submit, that you want to prepare, is related to this one lah, this lab materials. Okay, but don't the things that is that, because you are supposed to submit to me, because the things that you should change, you should change. For example here, okay, so this is the materials that I give it to you. So this is for I send to the students. So you can see lah, the purpose of the experiment is to help you, which is refer to yourself lah, to help students how to locate the center of pressure and compute hydrostatic force acting on a submerged plane. Okay, so this one you have to rephrase lah a bit. Okay, because this is my I mean the statement from the lecturer to students. Okay, when you want to submit the report to me, you have to rephrase lah, because this is the report that you prepare for yourself, what you have learned. Okay, so for example, the purpose of this laboratory report is to understand how to locate the center of pressure and compute the hydrostatic force. Okay, something like this one lah. Okay, so you have to rephrase lah. So like say macam objective here. Okay, objective no need to change lah, basically, because this is very general one. Okay, so is that okay? Faham tak the things that I explained?
Faham madam.
Okay, so basically dalam report tu you akan ambil semula daripada lab materials lah yang saya upload dalam e-learning. So but when you want to submit your report, you have to rephrase lah, yang mana sepatutnya you have to rephrase, lah, edit a bit. Some of the things that you want to change ataupun you want to add, so you can add. Okay. Okay, so I will brief for the first experiment. Actually, I plan to brief 3 experiments for today. Let's see lah, kita tengok yang mana kita sempat.
Okay, madam.
Okay, so this is under fluid mechanics, hydrostatic force and center of pressure. Okay, so the first experiment is to help the students, okay, how to locate the center of pressure and compute the hydrostatic force acting on submerged plane. Okay, so there are two main objectives for the first experiment: to determine experimentally the hydrostatic force acting on a submerged plane and to determine the experimental and theoretical center of pressure. Okay, so there are some theory that you have to understand about this concept, especially on how it works and also some of the equation. Okay. Okay, so here we have two figures, figure 1a and figure 1b. Okay, so the two figures are different in terms of partly submerged and fully submerged. The figure explain about physical dimensions. Okay, the concept ataupun teori for the submerged untuk dua-dua figure is the same. Okay. Okay, so dekat figure ni ada label, right? So we have some labels about the D, F, C, P and so on, the B. Okay, so this is the meaning for each symbol. The D is the depth of the submersion. F is the hydrostatic thrust exerted on the quadrant. H is the depth of the centroid. H prime and H double prime. Okay. Is the depth of a center. H double prime is the distance of the line of actions of thrust below the pivot. Okay. So sini So sini ada H. So sini ada H prime. So sini ada H double prime. Okay. Okay. So on this hydrostatic force. So force equation untuk force is defined by this equation. The rho, G, A and H. Okay, so meaning tadi samalah. H dia is the depth of centroid. H kalau tak diberi, then you have to evaluate which is equal to D over 2. A is the area of the quadrant. Okay, we can compute area of the quadrant as B times D. B times D ni untuk partly submerged surface based on figure 1 lah. Okay. So kalau kita substitutekan equation A dengan H into your punya this first equation, so you dapat first equation dalam bentuk equation yang baru lah, which is this here as shown dalam equation 1A. So untuk case fully submerged surface, okay, equation H dengan A is a bit different. H is here lah, D minus D over 2. A is equal to B times D. And then, so kalau kita ganti these two equation masuk dalam equation force yang basic ni tadi, then you will get equation 1B. Okay, so equations means that the basic equation dia tadi F, but kita ada expression yang berbeza untuk H dengan A. Okay, so untuk case partly submerged dengan fully submerged, you will be having hydrostatic force in terms of two different equations. 1A is for partly, 1B is for fully submerged surface. Okay, so next kita proceed to the experimental depth of center of pressure. So this experimental depth of center of pressure relate dengan moment. So this moment you belajar dalam subjek apa? Ingat tak basic moment? First time you jumpa moment ni masa bila?
Fisik.
Physics. Dalam Maths 2 pun ada lah, but mostly dia guna dalam equation yang ada derivative. Okay. So moment equation M is equal to F times H double prime. This one H double prime ni derivative lah. Okay. So kalau moment is balanced, so it will be produced by the weight W. Okay. Apply to the hanger at the end of the balance arm. So this moment basically ataupun theoretically is proportional to the length of the balance arm L. Okay. So that means moment tu can be expressed in terms of balance arm L. Tapi untuk case static equilibrium, two moments are equal. Okay. Two moments are equal. That means you can have this one yang tadi kan atas. So you can have in terms of weight times with you punya length of balance arm. Okay. Ataupun dia sama dengan M times G times L. Okay. So tadi you learned about the hydrostatic of the derived hydrostatic thrust kan. From 1A. Which comes from you punya partly submerged. Okay. So you can use the equation. Relatekan dalam ni. Then you can have the moment new equations. Okay, in terms of here lah. H double prime is equal to mgl divided by F ataupun mgl divided by rho bd squared. Okay, rho bd squared ni daripada equation 1A lah. Okay, so ada relation antara moment dengan you punya partly submerged tadi. Okay. Okay, kalau kita relate dia kepada equation 1B, then you have a different equation lah, something like this one. So despite kita tak pergi detail, tak ada masalah kan, because you already pass Maths 2, right? Maths subject you already pass kan?
Yes, madam.
Okay, next we proceed to the theoretical depth of center of pressure. Okay, so equations for this theoretical result for depth here is been labeled by H prime. Okay, so it is equal to Ix over AH. Ix is the symbol untuk second moment of area of immersed sections about axis in the free surface. Okay, so I'm not sure you jumpa kat mana this one. Parallel axis theorem. Madam pun tak pernah jumpa this theorem. Okay, did you see here dalam fluid mechanics ke? I'm not sure, is it? Ada ke belajar? Parallel axis theorem. Ada tak? Pernah belajar tak this one? Ada jumpa tak? Subjek mana Parallel axis theorem?
Fluid mechanics.
Fluid mechanics Okay, so this is lah This one Madam pun tak tahu sebab Madam pun tak pernah belajar fluid mechanics kan. Okay, so daripada equations 1A, so kalau kita masuk ataupun relate dia dengan H prime, so you punya second moment of area of immersed section, okay, boleh tukar dalam bentuk yang barulah Ix ni. Cuma dia ni, this equation relate kepada equation yang partly submerged. So you dapat equation 3. Okay, daripada rajah 1A tadi, the depth of center of pressure below the pivot is given by this one lah, H double prime. Okay, so since kita ada dua equation, so satu equation yang ketiga ni, okay, equation yang ketiga ni, so kita masukkan equation ketiga ni masuk dalam equation kedua. Okay, sebab sini equation 3 ni adalah equation untuk Ix kan, second moment of area. Dan kita masuk dalam equation kedua sebab sini ada Ix. So you boleh dapat new form equation baru dalam bentuk H double prime. Okay, so you dapatlah equation 4. So equation 4 adalah hasil daripada kita substitutekan equation 3 masuk dalam equation 2 lah. So kita dapat sini Okay, and then untuk case fully submerged, you boleh buat lebih kurang yang sama, tapi kita akan guna equation 1B. Untuk fully submerged, kita dapat Ix. Equation Ix yang bentuk ni lah equation 5. Dan untuk dia punya depth is equation 6. So equation 6, dalam equation 1b kita ada 1b kita ada equation for fully submerged kan, ataupun 1b tadi dia dah jadi equation 2 kan. So kita ada equation 2. So equation 5 yang ni Ix masuk dalam equation 2. Because sini kita ada Ix. So you dapat new equation lah in terms of you punya H double prime. Okay. So H double prime means depth of the center of pressure. Okay. So untuk eksperimen setup so this is the detail so kita ada contoh figure. Okay, basically nanti dalam masa you jumpa technician kan, because you have to discuss lah with the technician which experiment that you nak dia demo. Okay, kalau ada part of experiment yang you rasa you okay without experimental setup and so on lah, macam you tak perlu demonstration, you nak certain some of the experiment saja yang you nak demonstration, but try to have lah discuss dengan the technicians Okay, so untuk experimental setup, so this is the figure lah. Okay, so untuk hydrostatic force and center of pressure apparatus, so this dekat sini you akan faham lah konsep dekat mana yang you punya H, you punya pressure, you punya depth and so on lah. For this figure lah dia tunjuk, cuma figure ni tak berapa terang you can zoom later on lah Okay, so the apparatus comprise a transparent measuring container. So dalam container ni you ada this one lah, transparent measuring container that is filled with water. And you ada scale. I'm not sure lah whether this one you have it in the lab or not but you can ask lah later on the technicians A scale on the tank permits the water levels to be read off with precision. The counterbalance tank swivels on a bearing when the tank angle is set to 0 using a lever with appropriate weights. The force acting on the surface can be determined. Okay, so means that dia macam seimbang lah. So you can measure lah dia punya force acting Okay, so this is the detail for the procedure. Okay, step 1, adjust the counterweight. Number 2, add up water to some level. Okay, and then there are some item lah you need to take notes lah. Make sure water level leave part of the vertical face exposed. Okay, number 3, add weight to restore the beam. Number 4, measure and record you punya H. Okay, so you punya record H ni you kena isi lah dalam you punya lab sheets Ada lab sheet that you have to isi. And then number 5, calculate you punya H prime and compare to you punya H double prime. Okay, so it's this item that you need to know lah. If your values are not reasonably close, then check you punya measurement. So something wrong you have to know lah. And then return to steps 2 to repeat and so on. Okay. Okay, so untuk you punya data collections and something that you need to calculate or compute, some analysis you need to do lah. Okay, first one, you must have a table containing your data, calculate and plot relevant graph to show your result. Example, relationship between you punya force and the D. And then you punya H double prime and D. And or you can have H prime with H double prime. Okay, so if you have these three relationship, then will be good lah. Okay, that means you confirm lah dapat A kalau you have extra. Your report covered extra items lah Okay, and then in your report, make sure you show your sample calculation, how it can be computed and so on. And then observe you punya primary trend. Okay, maksudnya let's say you nak investigate antara H dengan water depth. Okay, so mungkin on certain situation you have first trend, maybe you see, let's say kalau dia increase, so what happen? Maybe another variable that you investigate will be also increase So kita nak tahu trend, sama ada trend dia dua-dua naik ataupun dua-dua turun ataupun dia berbeza. Okay, for example. And then in your report you need to justify lah whether the experiment that you do is consistent with the theory or not. Okay, you need to mention lah. Okay. Okay, so and then you should have one paragraph to discuss lah, or discussing including you punya interpretations lah, one paragraph so the item number 7 here just one paragraph. Okay, and then calculate percentage of relative error, because kita nak tengok berapa beza right between you punya two computed value. So you can compare. So you need to justify lah. You sini you apply pengiraan antara absolute error kat sini, konsep absolute error ataupun relative error. So this part you have already learned in engineering mathematics 3 So you need to recall back theory or the concept, how you justify. So dekat sini dalam lab material just mention percentage of error. Okay, so kita tak letak what is the types of error, but in your report you should be specific. What types of error? Absolute error ke ataupun relative error? Okay, and then end with your recommendations. Recommendation means of course lah, bila you buat eksperimen maybe you tak dapat exactly tepat-tepat kan with the actual one, but you can provide recommendations how to improve the error of the experiment so that you punya result lagi better. Okay, so these recommendations kalau tak tahu then cari dalam buku lah. Okay, maybe some of the experiment you have done ataupun this topic similar to another subject before this that you have learned, then you can add some the one that you learn lah as recommendations help to improve the error of experiment. Okay, is there anything that you want to ask? Anything you want to ask?
No, madam.
Tak ada madam.
So far okay ke lab eksperimen 1 ni? Okay, kalau nak tanya detail daripada segi tu, I think maybe you all lagi biasa jumpa with the equation kan? Dia tak? Masih nak tanya? Okay, kelas hari ni apa? Madam record tapi nanti lambat sikit upload lah sebab Madam use apps lah. Okay, so saya sambung eksperimen 2 Aku tak ada soalan nak tanya ni. Boleh saya sambung eksperimen 2?
Boleh, madam.
Experiment 2 is on deadweight pressure gauge calibrator. So basically dia is dalam course information adalah untuk CLO number 5. Okay. Okay, untuk second experiment ni is you kena study the working of Bowden pressure gauge. Okay, and to check the calibration of the gauge in the deadweight pressure gauge calibration setup. Okay, kejap Madam rasa Madam lupa lah tadi nak play video. I think ada video. Kejap saya play dulu video eksperimen 1 terlupa. Kejap. Sekejap lambat pula Sorry saya back dulu. Sekejap lambat pula Sekejap saya paste dekat tempat lain. Boleh dengar sound ke?
Tak, madam.
Kejap. Tak boleh dengar sound.
Today we're going to perform our third laboratory experiment, which is to determine the hydrostatic force on a submerged or fully immersed surface.
Tak boleh dengar Saya pun tak ingat hari tu should be share screen. Okay. Kejap.
And finding
Dengar?
the center of pressure.
Madam.
Boleh?
Boleh.
Okay.
Boleh, madam.
Today we're going to talk about our third lab session for our Introduction to Fluid Mechanics course, that is hydrostatic force or center of pressure. The learning objective for this lab is to determine the hydrostatic force acting the position of center. Like always, review concept before we go cover theory and show you the demonstration. Hydrostatic force, we also talked about this in a previous lab lecture. It is the pressure exerted by a fluid at rest, so the fluid is not moving, on a submerged surface, so the pressure on a submerged surface at a given point. Center of pressure, it is a point on a submerged surface, the surface that is underwater, partially or fully, at which the hydrostatic pressure force is acting. So the line of action, the point where the line of force is acting is the center of pressure. One thing, if you see, for definition of hydrostatic force, we told you that hydrostatic force is the pressure exerted by a fluid. But we know force and pressure are not the same. Force, if you divide force with the cross-section area, you get pressure. So how do we saying that hydrostatic force is a pressure? I think the easier way to understand is that to introduce the term, which is the third term here, equivalent normal hydrostatic force. We can define it as a force that is equivalent to pressure. How? If you see the equation on your left, P is the pressure equals to force over area equals to the specific weight of water multiplied by the depth from the water surface to the centroid of the element. So if the surface we're talking about, the centroid of that surface from the water surface. Now if I take the area on the right side, now I can get the force F. If you see the second equation, the force representing the pressure, and that's why we call equivalent normal hydrostatic force. So it is equivalent to the pressure. So let us introduce ourselves with our apparatus. We have the level indicator here. I will show you the other side. There is 3 mark. We have to use the middle line. We also have the balance arm. This is the balance arm. This surface is flat, so we have to align the flat surface of the balance arm with the middle line of the indicator. We also have the
clamping screw here, we don't have to mess with this one. And here we have knife edge pivot. So this is just knife edge here, and it's just standing both sides on the clamp. And we have the counterbalance to balance the empty tank, to balance the quadrant. And we also have a scale. We're going to use the scale that is attached to the surface of the quadrant. And this is the quadrant itself, see in orange. And we have a drain valve, because we're going to fill up this tank, and when we want to drain, we're going to turn it on, and it will drain itself. We also have our weight hanger here, and we also have our weight to attach here, which is our, we also have a groove here to hang the weight hanger.
Our experiment today is very simple concept that is built on its moment. We already know what is moment. If you see the arrangement here, the red circle, if we take a moment about that point, on the left you see there is a weight mg. If you hang a weight, mass into gravitational acceleration z, which is weight, multiplied by the L is the moment, which would be counterclockwise. And if you take the other force that is acting on the surface, if you see this line here, which is the water surface, and this is the submerged surface, and if your center of pressure acting on this point F, we can get again the moment F multiplied by the distance, which is h prime r, and on a balanced equilibrium condition, the equilibrium moment equation would be this mgl equals to fhr. Now, our goal, as I said, as we told you before, to find the equivalent hydrostatic F. Now, the equation F and the location of center of pressure, that is our two goal, right? Those two equations are different for partially submerged surface and
okay, so yang ni because dia ada guna simbol a bit lain sikit kan. So saya skip part ni So nanti bila untuk lab report, you can use daripada lab materials lah yang saya bagi dalam PDF tu lah Use that one lah, because kat sini basically symbol dia a bit different lah. Okay, but actually it is equivalent je at the end, dia sama je. Okay.
Okay, madam.
So ni step tadi cara nak kira.
like I said, I'm going to give you the fixed value. The apparatus we're going to use, as we showed you earlier. So these are the data we have to collect for each that weight you add. Collect at least 3 data, because we'll be using our eye level to get data. There could be little off, and take average would be nice. So let's see how should we do the test.
I need you need, we need a break. Jom rehat sebentar bersama KitKat. Have a break.
Uniforms stay white and new with Vanish.
So let's start by balancing our apparatus. If you see the air bubble inside the black circle, that means our apparatus is leveled with the surface. And if it's not, all you have to do is change the stopper to make it balanced. To avoid any surface tension or any bubble formation, because we're going to add water into the tank, what I'm going to do is to take a weight napkin and take this quadrant out, and I'll just rub the surface, making it white, In that way, the surface tension, any surface tension, will be avoided, and also it will avoid any bubble formation. So I'm rubbing both sides. I'll put it back. Okay. Now I'm also gonna check if it's still free to move. So you see it's moving. So it is free to move. So we can start our test. So next I'm going to put the empty weight hanger to its groove. Now it's not moving. Now I have to balance the setup by moving the counterbalance. So let's take a closer look of our balance. If you see the balance indicator, the center mark is aligned with the balance arm, and the view will be changing where you're looking at. You should be placing your head parallel to the center line to see if they're aligned. If you're looking from angle, you will not be able to balance it perfectly. So now I'm going to add some weight to my weight hanger. Now I have to start adding water. Before I add water, I have to check if my stopper is in closed position, otherwise the water will go out. I took water in a beaker. I have to be careful is that when I pour the water into the tank, I have to be careful not to put water on top of this surface or on the curved surface, top curved surface, because that will disturb the movement. So I'm carefully pouring water. I have to keep adding water until the balance again become level with the middle index. So I will just keep adding water. It went up. I have spilled some water on the curved surface, so what I'm gonna do is that take this water out from the surface. So if I see closer, the balance went beyond the middle mark here, so I can drain some water to bring it down. You see water is going out to the drain, and yeah, it's aligned. Let's take a closer look with our 50 gram weight, and we drained some water out, so the balance is almost aligned with the center line. So after balancing the quadrant, now we have to take the reading from the scale. We have to be careful for the meniscus. If you remember on the previous lab, we talked about meniscus. So again, we have to take the data at the bottom of the meniscus. So you have to align your head at the surface, bottom surface of the meniscus, and take the reading. What we see here is around 49. Little bit less than 50, so 49 millimeter. Next, we have to repeat the test by adding more weights. We added 50.
Okay, so yang ni baru first one try kan, so you have to do for other measurement lah kan, right?
Okay, madam. Dia berapa kali madam cuba kita buat? 3 ke?
Kalau ikutkan tadi, dekat dia punya tu dia ada table tadi dekat awal-awal video tadi. Dia ada tunjuk table tu berapa banyak reading yang dia nak buat kan. Okay, so kalau untuk apa ni?
Untuk kita based on lab sheet kita ke?
Lab sheet you.
Okay.
So So you tengok nanti Hmm. Okay, so basically kalau dekat video tadi pun the apa ni, the person in charge tu dia ada mention jugalah what to avoid tu kan. Apa yang you kena elakkan, so on tu dia boleh jadi you can include as recommendation lah dalam report you. Okay, so perasan kan dekat sini untuk write report saya ada letak kat sebahagian, ada bahagian references, right? So video tadi tu you can include lah as references, and then kalau you ada guna video lain ataupun sources lain daripada maybe some lecture notes from overseas punya university, you can include lah dalam references ni. Okay, masukkan. So jangan tinggalkan kosong lah references ni. At least you have ada 3 or 4 references should be good lah. Okay, and then some of the things lah kan, you tengok dekat bahagian discussion, maybe as suggestion lah kalau untuk you tambah supaya report you could be better. So from the video tadi dia ada mentions lah about all the concept and theory. Maybe you can include on, let's say this concept nanti you akan jumpa pada bila in your engineering field bila you kerja nanti. Okay, so you can include juga dalam as discussions. Okay, ada soalan tak?
Okay, medium.
Okay, so kita nak pergi eksperimen kedua. Okay, so eksperimen kedua tadi untuk verify salah satu prinsip dalam fluid mechanics. So the objective is to carry out the conformations of the readings of Bowden manometer using Petron equipment of calibrated weights. Okay, so this is one of the things tool lah, right? But Bowden manometer. So this tool is used to measure of pressure and vacuum, and this tool is suitable for all clean and non-clogging liquid and gaseous media. Okay, so this one you can read later on lah. Okay, so ada beberapa jenis manometer start. So let's see figure 1. This is gambar pun tak berapa clear because saya dapat ni daripada from other lecturer lah. Okay, so this manometer figure 1 is called Bowden tube. Okay, so sini you ada scale, the tube, the tip, the adjustable link, the segment lever. I'm not sure this is pivot ke sector, partition spring, the stop, the socket. Okay, so kalau you nak masukkan figure, because figure ni tak berapa clear kan, so kalau dalam report you can cari yang figure lain, but later on you can include lah that figure tu daripada sources mana. Okay. So the manometer is regarding what consists a hollow metal tube with an oval cross sections bent in the shape of a hook. Okay, so one end of the tube is closed, the other open and connected to the measurement region. So if the pressure is applied, the oval cross section will become circular, and at the same time the tube will straighten out slightly. So the resulting motions of the closed end proportional to the pressure can be measured using pointer or needle connected to the end through a suitable linkage. Okay, so tadi kita nak understand about the principle of mechanics. So from this manometer, what you can learn is about pressure in a fluid. Okay. Okay, so the fluids are unable to support shear stress. Okay, because when immerse a body in a fluid like water, the fluids develops a force that perpendicular to the surface of the body in each point of the surface. Okay, so the pressure for this fluid is measured by this one lah, symbol P kan. Okay, so I think you are familiar lah with this pressure equation. P is equal divided by F divided by A. Okay, so the unit for the pressure is Pascal. Okay, this is SI units, right? International punya standard kan, Pascal. So we have other units lah, tapi kalau kita nak measure based on SI unit, so we use Pascal, not other types of units lah. Okay, so the setup for the experiments, so it consists dalam figure ni, you have what? A cylinder. Okay, cylinder. So the cylinder ni is interior precision piston slips. Okay, it is able to set in the cylinder a certain number of predetermined pressure. Predetermined pressure ni maksud dia pressure tu dia boleh di-evaluated lah ataupun boleh ditentukan lah using system of calibrated weights. So weights ni you boleh calibrate lah, adjust with your punya pressures. Okay. So the Bourdon manometer is connected to the cylinder, a flexible tube. Okay, so something like this one lah figure. This is some of the things ataupun tools, important tools that you have lah for this second experiment. Okay, so the step, first one, place the equipment on a flat and even surface, connect the supply tube, and then you need to make sure for the manometer, it should be, the output can be measured, should be prolonged. That means a flexible tube from the drainage faucet until it's free and is settled inside an empty recipient to avoid splashes. Okay, step 2, disassemble the piston and determine accurately the weight. Step 3, determine the weight of the masses. Step 4, cover the piston with Vaseline for a best operations. Step 5, open the faucet of the manometer. Step 6, put one valve in the flexible tube that comes from the upper part of the cylinder. Okay, need to make sure after that you need to close the output force of the manometer and immediately later stop introducing water in the equipment. Okay. Step 7, introduce the piston totally inside the cylinder. Okay, step 8, repeat the steps adding to the piston. Step 7 ni kena repeat in a staggered way. And step 9, remove the piston and dry. Okay, and then empty the cylinder. Step 10, make sure that you don't leave the piston inside the cylinder when you do not want it to be used later on. Okay. Okay, so guideline for the calculations and data collections. Okay, you have a table, tabulate data in the table, compute and plot relevant graph to show your result. So kat sini ada guna graph lah. So graph is on the absolute error in the functions of the real pressure in the manometer and graph of your relative error. So kat sini ada dua jenis error that you need to show for your data collections. Okay, and then find out possible discrepancy among the values. Okay, maksudnya
Madam, saya tak nampak apa screen tu.
saya tak nampak. Oh, sorry. Saya dah banyak habis ni. Sorry.
Tak apa, Madam.
Sorry. Okay, nampak tadi dah banyak dah tadi.
Nampak, Madam.
Ini step tadi dalam prosedur. Roughly lah Okay, and then untuk yang data collection, okay. Kat sini saya sambung kat sini. Find out possible discrepancy among the values of your contrasted manometer. So ada nilai yang kontra tu masa you kira ataupun measure daripada manometer should be ada macam certain range lah yang can be possible lah. Okay. and the value of the pressure computed inside the cylinder. Okay, so this is you punya data collection lah, ataupun things that you need to compute lah. Okay, so first step tadi dekat you punya graph of absolute error, and also you punya graph in terms of relative error lah. Okay, so things that you should include in your discussion, you need to interpret results. So, okay, interpret result. Lebih kurang sama macam eksperimen satu lah. Okay, but there is the explanation ataupun discussion mesti explain how the object of the experiment was accomplished. Okay, accomplished. So, if any analytical expression is to be verified, maksudnya daripada you measure dengan you punya actual lah, kan? So you can have the percentage error. So dekat sini pun another case, dalam lab sheet eksperimen kedua ni, dia punya percentage error just give as generally, but in your report you should be specific lah what is the types of error here. Okay. And then recommendation include lah how to improve the error, of experiment. Saya rasa ni salah kot ni. Should not to improve lah, I think should be reduce kan. Bila kita buat eksperimen mesti ada error, so mesti nak reducekan error tu lah, right? Kalau improve error ni macam you salah kira banyak, macam tu lah. Okay, so yang ni bukan how to improve, how to reduce the error of experiment. So you should put recommendation lah, what is the things. Okay, so untuk yang ni pun saya share a bit video. Kejap. Pressure measurement. Tapi ada dua video kejap saya play. Lambat sikit, sorry kalau buka dalam ini. Boleh dengar tak? Boleh dengar?
Wait.
Boleh dengar kan?
Boleh.
Audio preview.
Okay, kita ada satu lagi Sure.
Kulit lebih smooth, rasa lebih confident, memang sangat-sangat puas hati.
Monza.com makes GANs great again. Yeah, you know what? I'm not going to say again because they never were, and they're complicated. See, with Monza.com.
This is the pressure gauge apparatus, and in this experiment, we are
Okay, boleh dengar sound?
Tak ada. Tak ada minum.
Calibration, okay.
going to calibrate this pressure gauge. For calibration,
Okey, dia dengar.
we need to compare the gauge.
Pula ni.
This is the pressure gauge apparatus, and in this experiment, we are going to calibrate this pressure gauge. For calibration, we need to compare the gauge reading with actual pressure. So first, we need to remove this piston part. Here we are using water as the liquid. So we need to first fill water in the cylinder. And then the piston should be replaced, and we should allow it to settle. And then we must make sure that there are no any air bubbles in this transparent tube. For that, we can just adjust this piston like this and remove the air bubbles. And then the first thing is we need to note down the piston area and total mass of the piston part. Here in this note, you can see the piston area and the mass of the piston. Piston mass is 1 kilogram and the area is 315 square millimeters. That's given in this label. So you should first note down that, and then we can take the initial reading. Initial reading then will be follow this 1 kilogram. You can read the gauge reading. Here the first reading is 30 kilonewtons per square meter. You can just take that simply. Then we are going to add these weights one by one and take the corresponding reading. So let's do one reading. This is 1 kilogram of weight. So we are going to add this weight, and you have to wait some time to settle this. To settle, you can just do like this, the piston. For 1 kilogram, you can again take the reading here. Likewise, without replacing removing the first load, you have to load all these weights and take the corresponding reading. And after adding all these weights, you have to remove one by one and have the reading at each remove. Now the experiment is over there, and then you have to calculate the actual pressure, because we are going to compare the actual reading, actual pressure with the gauge reading. So for calculate actual pressure, you know the load. The pressure equals load divided by area. So we are going to use that. Here for 1 kilogram, and this piston, the whole weight is 2 kilogram. For 2 kilogram, you have to calculate the pressure. You need to first convert this weight into force in newtons, and then you need this area, piston area. For that, we can use a vernier caliper. You have to just remove this, and this is the area. So we can use a vernier caliper and measure the diameter. And so that's the end of the experiment.
Okay. Okay, so ada nak tanya tak untuk tu? Okay, so rasa medium stop dululah. Cuma kan, boleh tak kita cari satu lagi slot waktu lain untuk apa ni, kelas extra, sebab saya takut saya tak sempat nak habiskan kan.
Bila tu madam?
So boleh bincanglah bila you're free kan. Tapi macam hari Isnin mungkin ke ada tak waktu free, dapat 1 jam pun tak apa. So recording ni saya tutup